So dear participants, let's resume with our discussions on ladder diagrams, and more specifically from this lecture onwards we will see that how the language of this ladder is employed to program the PLCs. Now you see that when we are talking of writing a ladder program, this is very much equivalent to draw a switching circuit. A switching circuit that corresponds to the control process. As usual convention of sketching the ladder diagrams, here also there are two vertical lines that actually represent the power rails, and whatever the control elements are, they are connected as horizontal lines, which constitutes the rungs of the ladder between the two verticals. So that's why it resembles just a ladder with two vertical bars and horizontal lines in between them. Therefore, it is the ladder diagram. On one hand, you can use specially designed programming terminals for programming the PLCs. Every manufacturer of PLCs have got their dedicated terminals. In the terminal you have a versatile keypad with necessary keys and symbols that give you various elements of the ladder diagram, and you can enter them into the program, while everything that you actually want to enter into the program, all the things are visible on a screen that is a part of that programming terminal. So that programming terminal is having a screen and number of switches. In the switches you can find necessary keys through which you can insert the control elements that are required in a process, and it is the work of the terminal to translate the program so that they can be directly fed to the PLC. Otherwise, what we normally do, or you will find that it is being also done very extensively, you can use your computer to draw up the ladder diagrams. But for that purpose, your computer should have the relevant software, because if you want that a PLC which is manufactured by Allen Bradley has to be programmed, then your computer should be either loaded with RSLogix or CCW software, connected components workbench as the manufacturers say, and you have to draw the ladder diagram, develop the program within that software atmosphere. Then you have to connect your PLC to the software, and then through some standard procedure you need to feed your program to the PLC. Remember that the PLC should be in stopped condition while you are programming the same. Therefore, there is simple software interlocking in the PLC, so that under any circumstances you cannot program a PLC when it is in running condition. If you are using Mitsubishi PLCs, then MelSoft GX Developer is the software platform, or if you are using the Siemens PLCs, then Step 7 Micro, Win V4, or the Legacy Total Integrated Automation TIA platform you have to install in your system, that means your computer. The software operates just like other Windows operating system. They involve selecting several items that are there on the toolbars, just you use in Word operation or Excel operation or PowerPoint operation. There are several pull down menus from which you can select which particular parameter you want to use, that you can put onto the control diagram or the ladder diagram. You can see here, this is RxLogix 500 software platform, and this is what you can see in front of you. This is the editor screen. You can see the ladder here. This is the ladder, the two power rails of the ladder. In between there are the rungs. This is rung 1, rung 2, rung 3, rung 4, and finally the end rung is there. In the rungs you actually insert different control components. You can see here these are the input components and this is the output component. You can choose them from such type of toolbar, and they are all menu driven, very simple. The person who understands how to use the basic Windows features, he will be able to get very much expert in ladder diagram if he understands the process and the control method of that process. Then the thing becomes very easy. If you do not understand the process properly, then you can be a great programmer, but you will not be able to do proper justice with a ladder diagram, because the ladder diagram, drawing a ladder diagram, that may not ask for a high expertise in your programming capacity. It asks your intuition towards understanding the process properly. You should know very clearly that how you are going to control it, and accordingly the control elements, whether it may be the input side, whether it may be the output side, have to be put in this ladder. So such type of software platform is there. Now what are the convention in ladder diagram drawing? That we should know very clearly. But before that, let me just show you one operation with a ladder. I will be using WPL Soft, that is a software of Delta Automation. I will try to draw a new project. Let us give some name. The program title should be Unit 1. You can see, and the file name should be test1. You can make it as per your will. We are using a PLC here. You can see that you can program different elements. So we are using a PLC here, and the model that is given, it is SV2, one of the entry grade model PLCs of Delta Automation. Although we will be working in the simulation mode, therefore such type of communication settings and all, they do not make much difference for us, but still whenever you are trying to actually program the PLC, then you need to take care of different parameters that are under this particular pull down menu. So we will go for it, and you can see here there are two particular options. One is you can see the instruction list is there. Here is the ladder diagram mode. So whenever we are actually drawing the diagram, the according instructions are automatically built up here. So we will be concentrating on the ladder diagram. We will fine. This is the editor screen with us. So in the very beginning, what we should do, we should know what we are trying to do. I will just add one switch. It will be a normal open switch, and I will bring another element at the output, which is simply a coil of a relay, coil of a solenoid, so that whenever the coil is activated, some actuator which is attached at the NO terminal or NC terminal of that coil can be activated. Now you see, I will be taking this input. Here you can see, as every input needs a dedicated address, here the input name is given as X and the device number is 0. You can also find that the range is given here X0 to X377. That means there are in all 378 input devices that you can add here. There are this much number of input addresses. Okay, you can see here this is an input relay. You can name it also through the comment bar. Let's make the name input, or I will take a short one. Let's take INP. Okay, so we put it over there. So this becomes INP. This is your input, and we have nothing to do more right now. What we will do, we will take a simple coil at the output. Now you see, since it is output coil, it is showing Y. What are the other choices you can see over here? You can have this M and S. What is this M and S? That I will come at later part of our discussion when the things will arise. So for now, the output, simple output coil is denoted by Y, and we will be giving the name here OP, that is stands for output. So this is the thing. Okay, there is an input switch and there is an output coil. You might wonder that here no this rail is given. This is the convention that has been used by Delta. So on the left side you have the power, and on the right side there is also the power, but actually it is not shown here. It is not shown, it is by implicit. Okay, now let us see what is actually how it works. Okay, so for that we need to get this thing first of all in this simulation mode. I now have taken it to the simulator mode. In order to compile this, you need to get into this particular button. Now it is compiled. You can see here this is end switch has come. You can also find here in the instruction lead mode, accordingly the instruction has been generated. Now what we will do, we will take this inside the PLC. You can see the communication mode, PC to PLC, it is done. If it was an actual PLC and we were not in a simulation mode, then some more parameters would have been asked by you if the communications are not properly I should say configured, and then we have to, okay fine, we have downloaded it. We have to get this system online so that we can see the PLC is right now in stop mode, and now this is run. This is the stop button, this is the run button. We have made the PLC in run mode because you cannot make any changes when the PLC is in stop mode. Now you see here, I will take this switch. Okay, here actually I mean a push button with NO contact, but here my mouse is not a push type thing na? So therefore I am doing a right click, I am putting it set on. Now when I have put it on, you can see your output is energized. Now your output is energized. So you can see that power flows from the left side to the right side. Power flows from the left side to the right side. This is an important aspect that you must know about a ladder diagram. So I hope that you have got the basic idea that how the ladder diagrams are made. I will stop this and I will get back to the discussion, and whenever some requirement is there, we will get back to this ladder editor and we will make the changes as and when it is required. So now let us get back to our discussion. You can see what are the conventions we were discussing about. We have got vertical lines that are there in the diagram that represent the power rails between which the circuits are connected. The power flow is taken to be from left hand vertical across the rung. We have already seen that power flow is there from the left hand vertical across the rung. Each rung on the ladder, they define one operation in the control process. So if you draw a rung, definitely that will signify one of the control process in the entire operation. Without necessity no rung can exist in a ladder diagram. Next point, remember, ladder diagram is read from left to right and from top to bottom. This process is called scanning. Now, who is reading the ladder diagram? The PLC is reading the ladder diagram. And whenever there is some problem during operation, then as the programmer, you also have to read the ladder diagram. So while reading the ladder diagram, you must properly conform your process and the switching elements, the contacts in the ladder diagram in this manner. You should start from top left, then you should move in the form of writing Z patterns. I will show you here. It is like this. You start from this point, the topmost left point, then you go through the rung, then you write a Z, start with rung 2 from left to right, come at rung 3, go from left to right, and accordingly you keep on moving. This is how the PLC actually scans a ladder program. But don't worry, the PLC is very fast because it has got microprocessor in its heart. So you need not to bother even if the program is very lengthy. Within fraction of seconds, the PLC is able to read the entire ladder program. Let's get back. Now you see, a ladder diagram is read from left to right and from top to bottom, and this process is called scanning. This we have already seen. Now you see, during scanning, the top rung is read from left to right. The top rung is read from left to right. Then comes the second rung. Again it is read from left to right, and this process is repeated till you come to end. And after coming back to the end, again you go back to the first rung, topmost rung in the left position. Now you see, when the PLC is in its run mode, it goes through the entire ladder diagram to the end. The end rung of the program is clearly denoted, and once it reaches the end, that means the PLC completes its scan for a single time, it promptly gets back to the start. Therefore, it is very important that you define the end for the PLC. Otherwise, it will not be able to understand that what it has to do now. So as you have seen in that particular Delta software, whenever we compile the program, automatically the end thing is created. Now after the end is there, the PLC immediately goes back and resumes at the start. Now the process of going through all the rungs while executing the program is termed as a cycle. Next part, you see that end rung should be indicated by a block with the word end or return, because then only the program will promptly return to its beginning. Let us see what is the scan time. The scan time depends definitely on the number of rungs in the program. If you have a 2-rung program, it will be scanned very quickly, and if it is a lengthy program, then the scan time will be definitely more. Now you see, it takes about 1 millisecond per 1000 bytes of program. So typically for scanning one single rung, the time required, no, I think that I'm getting something confused about. You see, for 1000 byte of program, 1 millisecond is required, and likewise while reading a complete program of say considerable length, you require a total time of 10 millisecond to 50 millisecond, which is not a big deal of time. Even before you can understand the entire process is complete. Now you see that this is the thing that we have already discussed. Now you concentrate on the right side. Here you see what actually is done by the PLC at the initial level. It reads the status of all the inputs and store them in memory. Right? Then it scans the program and read the inputs from memory and implement the same in the program. When it moves along this, it feels that wherever the input is required, it actually gets the value of the input from the memory and storing the output values in the memory again. So whatever it do, at the outset of the program, at the starting point of the program, it reads all the inputs and store their values in memory. During the program, wherever the program finds the requirement of inputs, it will get that particular value of that input into the program, do necessary logical or mathematical operation onto that, and stores the output value again in the memory. It stores the output value again in the memory. Finally, after the entire scanning is complete, all outputs are simultaneously updated. This is one very important point that you should remember. Updatation of the outputs, they take all at a time after this complete cycle is over. So this is where we will stop today, and we will see with further conventional aspects in drawing the ladder diagrams for PLC programming in our next lecture. Thank you.